See, we know at STP, 1 mole of any gas will occupy 22.4 liters. At STP, 1 mole of a gas will have a volume of 22.4 liters. So as per the question, 5.6 liters implies 11 grams. Equate this to 22.4 liters. This will be 4 times. So we make it as x. The value of x is equal to 44 grams. This is nothing but the gram molecular weight of the gas. Gram molecular weight of the gas. So here, if we want to calculate number of atoms is given by number of moles into Avogadro number into atomicity. So atomicity is number of atoms present in the given molecule. But then asking for oxygen. So what is the number of oxygen atoms means it will be equal to 3. So now what is the mass of this sodium carbonate given? 10.6. So its molar mass will be 106 into 6 into 10 to the power of 20. 3 is Avogadro number into atomicity will be equal to 3. So that is 0.1 times, that is 0.3 into 6, 1.8 into 10 to the power of 23 oxygen atoms. So which of the following has maximum mass? Which of the following have maximum mass? So first one is 0.1 gram atom of carbon. So we need the mass. So how to get the mass? Mass is nothing but number of gram atoms into atomic mass. So mass is equal to number of gram atoms into gram atomic mass. So what is the number of gram atoms given? 0.1. What is the atomic mass of carbon? That is 12. That is 1.2 grams. Second case, number of moles is given. So what can be the mass now? Mass M is equal to, or mass is equal to number of moles into gram molecular weight, molar mass. So what is the number of moles? 0.1 into, so it will be 17. So 1.7 grams. And coming to 6 into 10 power 22 molecules of hydrogen. So how to get number of moles? Given number of molecules by Avogadro number. That is number of moles into 10 to the power of 22 divided by 6 into 10 power 23 into gram molecular weight of hydrogen. That is equal to 2. It is 0.2 grams. The last case, volume is given. Of course, should be at STP. So number of moles is nothing but given volume by gram molar volume. Given volume by gram molar volume into molar mass. So in this also mass is equal to the number of moles is given volume is 1120 divided by molar volume is 22,400 and molar mass of CO2 is how much? 44 grams. So this will be how many times? 20 times. 20. It's nothing but 2.2 grams, which is having the maximum mass now. That will be option number 4, because option 1 it is only 1.2 grams Option 2, 1.7 grams. Option 3, 0.2 grams. Option 4, 2.2 grams. So it will be option number 4. So approximate atomic weight of metal having specific heat 0.32 is. So generally, according to Dulong's Petit law, atomic weight and specific heat, the product of these two will be equal to 6.4. That is atomic weight into specific heat is equal to 6.4. So here atomic weight we have to calculate. You make it as x. What is specific heat given? 0.3 is equal to 6.4. Therefore, atomic weight is equal to 6.4 divided by 0.32. Otherwise, 640 divided by 32. So this is equal to 20. Yeah. So whenever the boron has two stable isotopes, one is B10 of 19% abundance and B11 of 81% abundance, then find the atomic mass that should be appear for boron in the periodic table. So generally we solve this as the average atomic mass of an element which is having different number of isotopes. So similarly, so average atomic mass is equal to atomic mass of the first isotope into its percentage abundance plus atomic mass of second isotope into its percentage abundance divided by the total abundance will be generally 100 because that is given in percentage. So now coming to the point. So what is A1 value? Nothing but atomic mass of the first isotope, that is 10 is given into 19 plus second one is given as 11, percentage is equal to 81 divided by total abundance will be 100. So on solving this, we will get it as 10.8. So 0.1 grams of a metal gave on reaction with dilute acid STP 34.2 ml of hydrogen gas. Find equivalent weight of the metal. So here use law of equivalence. So from this, number of equivalents of metal must be equal to number of equivalents of the hydrogen gas released. So number of equivalents of metal is equal to number of equivalents of hydrogen gas. See how to get the number of equivalents of the metal? Nothing but weight by equivalent weight, because for the metal they're asking to find out the equivalent weight. Coming to hydrogen, for hydrogen they are given volume of the hydrogen gas, not the mass. So that means in such a case, what we'll do is that given volume at STP ml divided by equivalent volume of hydrogen. So how to get the equivalent volume? We know that 1 mole of hydrogen, nothing but 2 grams will occupy 22.4 liters. What is the equivalent weight of hydrogen? That is 1 gram. This is the equivalent weight of the 1 gram hydrogen. So half of this means 11.2 liters. It's nothing but 11,200 ml. So that means we know the mass of the metal, we know the volume of hydrogen gas given, that is 34.2 ml, and equivalent volume is 11,200. So from this we can get the value. We can get the value. So what is the weight given? 0.1 divided by equivalent weight, we have to find out. That is equal to volume in ml. What is the volume in given? 34.2 ml divided by what is the equivalent volume of the hydrogen? 11,200. 11,200. So on solving this, we'll get the equivalent weight of the metal. So the value of E is equal to 32.7. Is the answer.